Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And today we are talking more about circle problems that have to do with our good friend Pythagoras. We're going to talk about one more awesome property, do an example, and be done with it. Let's get to it, shall we? And this property states that a chord of a circle, or it's about a chord of a circle. Now remember, a chord is any line segment where its endpoints are on the circle. So this is a chord right here. This is a chord. This is a chord. Anything, any line segment, the diameter is a chord. This is a chord. So any line segment whose endpoints are on the circle is called a chord of a circle. So in this particular example, we're talking about this chord, and all this is saying is that if I have a chord on a circle, and from the center of the circle, a perpendicular is drawn to the chord, it cuts the chord in half. We say it bisects the chord. In other words, from here to here is the same as from here to here, the same distance. And of course, we have an isosceles triangle here. That's why it works. It's from geometry and the isosceles triangle. And this is an isosceles triangle because the radius of a circle is constant throughout. So this radius and this radius, obviously, since it's in the same circle, will have the same length. All right, let me just demonstrate it for you. So I am going to draw a circle here. And oops, I always forget that. So I'll put it there and put it out like that. And we're done with the circle. And then I'm going to construct a chord. So I need a line segment. So anywhere, stop. So right there, and I've got a chord right there. That's fine. Escape. And I can move that chord wherever I want, and I'll do that a little bit later. And now I need to construct a perpendicular through the center and perpendicular to the chord. So I'm going to do that. Menu, construction, and I just need a perpendicular. So here, menu, perpendicular to that segment, bam, intersection point, escape, done. Okay, escape, and so I need that intersection point between here and here. So I got this and I got this. Okay, all right, so now we have it. I'm going to make it a little nicer. See if I can hide this line, and I'm just going to draw a line segment there so we can see it. Line segment right here. Okay, so we know it's perpendicular. Let's just make sure of that. Go ahead and measure it. Measurement, angle. So measuring this angle right here. And you can see it's 90 degrees. So we know it's perpendicular. And then the whole point of the theorem is that the distance from here to here is the same as the distance from here to here. In other words, if I draw a perpendicular line segment from the radius to a chord, it bisects the chord. So let's go ahead and measure that. Measure length. So from this point to this point is 5.14 centimeters. And then we'll go to the other points. Length from this point to this point, you will see, is also 5.14 centimeters. And let me drag those on top of each other just so as I adjust it, you will see. So if I move the chord this way, still the same. Move the chord this way, still the same. Make the circle smaller, those lengths are still the same. As long as the segment that I draw from the center of the circle is perpendicular to the chord of the circle, then it will cut it in half. It will bisect it. Again, from here to here, 4.47, from here to here, 4.7. All right, and that is quite helpful when answering some mathematical questions. A circle has a chord of length 10 centimeters. If the radius of the circle is 8 centimeters, find the shortest distance from the center of the circle to the chord. This is pretty simple. So we got a circle. Okay, and I'm just going to do some random chord. We'll make it blue. So I don't know, from here to here. Okay, and then we are told that the radius of the circle, well, first of all, we're told that this is of length 10. Okay, and then we'll say the center is here. And we're told that the radius of the circle is equal to 8. So I'm going to draw a radius right to this end, because that's going to help me out here in a second. And we are told the radius is 8. And you're going to want to draw it to an endpoint, you'll see here, because the way I'm going to figure this out is I am going to go ahead and draw a perpendicular from the center perpendicular to the chord right there. And if that line is drawn, it does exist, right? It cuts these segments in half. So from here, this is equal to this, so that means this is equal to 5, and this is a right angle. And this is the shortest distance from the center of the circle to the chord, because it's straight up and down. The shortest distance wouldn't be over here, from here to over here, or from here to here. It's straight up and down. So this distance we'll call x, and we have our friend the Pythagorean theorem, a squared plus b squared equals c squared. So I can say that x squared plus 5 squared is equal to 8 squared. X squared plus 25 is equal to 64. I subtract 25 from both sides. Bam, bam, bam. So I get 939. Is that right? 64, 50? Yeah, I guess it is. So x squared equals 39. So I take the square root of both sides and I get x equals the square root of 39 as the shortest distance from the center of the circle to the chord. So, hope you enjoyed that. I know I did, and with that, I am out!